right, here's your notes on Faraday's law. Okay, so basically it's going to look at the amount of charge you can find in 1 mole of electron by using Avogadro's number for the number of particles in a mole. So again, the Avogadro's number we talked about back in grade 10, 6.02 times 10 to the power of 23. Okay, we don't really have to remember and know that, but we're going to use Faraday's constant instead, which is in your data booklet. So the numerical value of charge on a mole of electrons is what we call Faraday's constant. A rounded value of 9.65 times 10 to the 4 coulombs per mole of electron is often used, and that's, I believe, what we're given in our data booklet. Okay, on page, it's on page 3 in our data booklet. Okay, Faraday's constant right here. Okay, so Faraday's law states that the amount of a substance produced or consumed in electrolysis reaction is directly proportional to the amount of charge that flows through the circuit. So the coefficients in the half reaction for the reduction represents the stoichiometric relationship. Okay, and so like if we have 1 ion of zinc, 2 electrons, okay, equals 1 zinc solid, okay, again, our ratio 1 to 2 to 1, so we have double the amount of moles of electrons, okay, that are kind of passing through. Okay, the Faraday constant, okay, can be used to convert electric charge into moles using the following relationship. Okay, so this is a formula you kind of have to memorize or get used to using. You can also use unit analysis, and we'll talk about that. Okay, but this is one that like sometimes is just easier to use as a formula. Okay, so the formula is moles of electrons, so Ne, okay, is equal to IT over F. Again, I, okay, is electric current measured in amps. Okay, T, time in seconds, and then F, okay, is Faraday's constant, that 9.65 times 10 to the 4 coulombs per moles of electron. Okay, remember with I, if amps are equal to coulombs per second, that helps a lot when you're doing unit analysis. Okay, one way to remember too, like if you just remember this formula and you forget like what I represents, okay, on page 2 of your data booklet, okay, you're given all of these. So like current is I, and then amps are coulombs per second. Okay, and so this kind of is just helpful if you're forgetting what the units are for something. They're all here and there to help you. Okay, here's some examples using that formula. Okay, and so again, the formula just will write here on the side. Okay, moles of electrons is equal to IT over F. Okay, so convert a current of 1.74 amps for 30 minutes to the amount of electrons. So again, the first thing we have to do is like convert the minutes to seconds. Okay, so for time, we got 30 minutes. We're going to times that by 60 seconds in 1 minute and get our answer. Okay, so we got 1.80 times 10 to the power of 3 seconds. Again, like just if you get used to kind of writing out I equals 1.74 coulombs over seconds, and F, Faraday's constant, 9.65 times 10 to the 4 coulombs per mole of electron. Okay, now we put it into our formula. So our moles of electron will equal I 1.74 coulombs per second times 1.8 times 10 to the 3 seconds divided by 9.65 times 10 to the 4 coulombs per mole of electrons. And so the seconds cancel seconds, coulombs with coulombs. And since we're dividing by like coulombs over moles of electrons, those come up, and that's we're given moles of electrons are equal to 0.0325 moles of electrons. Okay. What amount of electron is transferred in a cell that operates for 1.25 hours at a current of 0.150 amps? So again, we want to convert our time to 1.25 hours, okay, times there's 3,600 seconds in 1 hour. That's just 60 seconds, or 60 seconds in a minute and 60 minutes in an hour. And so for our hours, we get 4.50 times 10 to the 3 seconds. Okay, put it into our formula. So moles of electrons equals 0.150 amps, or coulombs per second, times number we just got, 4.50 times 10 to the 3 seconds, all divided by Faraday's constant, 9.65 times 10 to the 4 coulombs per, or mole of electron. Okay, and we got 6.99 times 10 to the negative 3 moles of electrons. Convert a current of 1.74 amps for 10 minutes into amount of electrons. So again, we're doing the same thing. I'm going to skip this one because it's the exact same as these past two. We're just converting this into seconds. Okay, how long in minutes will it take a current of 0.350 amps to transfer 0.1 mole of electrons? So this one's a little different. We have to rearrange our formula. So we got IT over F. Okay, so we want to solve for I, so we're going to, if we're getting I, so we're going to multiply both sides by F. So we got moles of electron times F divided by, or sorry, we're looking for T, and then we'll divide by I. So now we just put our numbers in. Remember, this T is going to be in seconds since it asks in minutes, so we'll convert that later on. So moles, 0.100 moles times 9.65 times 10 to the 4. Coulombs per mole. Okay, the moles cancel. And then divide it by 0.50 coulombs per second. So coulombs cancel and we get seconds. And our time in seconds is equal to 27,571. That's just rounded seconds. Okay, we want to convert that to minutes, so we're going to times it by, for every 1 minute, there's 60 seconds, and we got 460 minutes once we round it for our final answer. Okay, electroplating, so this is again the same as these ones here. Okay, we have our time, we have to convert that to seconds, and then this is already in amps, so we're using IT over F. Okay, this one, again, this is the same as this one, except we have to convert at the end. Instead of going to seconds, we have to find hours. Okay, and we'll do this one here because it's the only one that's different. We'll calculate the current required to transfer 0.015 moles of electrons in 20 minutes. So again, rearranging our original formula here. So I is going to equal moles of electrons times F divided by T. Okay, so I is equal to 0.015 moles times Faraday's constant, 9.65 times 10 to the 4 coulombs per mole of electron. Okay, divided by, we have to convert the 20 minutes, so we'll times it by 60 seconds in a minute, and we get 1,200 seconds. And so we get coulombs per second as our answer, which is equal to amps. And our answer should get 12 amps. Should get 1.2 amps. And now we only have two significant digits. All right, so that's kind of intro to finding moles of electrons using Faraday's constant. Now we'll actually get into some cell stoichiometry.